Okay, thanks. So if any of you want to switch to GARCH and MSGARCH model, well, there's an implementation now on R. So this is the presentation for the Markov switching GARCH package, which was implemented due to the need of our paper that David presented. So this was in collaboration with the Google Summer of Code 2016 of last year, and we have some plan for Google Summer of Code of 2017. So a bit of recap. This is the MSGARCH specification of AS and all 2004. Well, case-separated single regime conditional variance process, possibly case-separated conditional distribution, a Markov chain that link everything together. And what David didn't say, we assume zero mean process. So we expect that the mean have been filtered out of the process before modeling the volatility. So the core of the package is in C++, thanks to RCPP. Very, very similar to GARCH. If you have ever used that, you will be very familiar with the package. Functionality for visualization, simulation, model selection, and risk measure. So the building blocks of the MSGARCH model is the single regime model. So in the package, we have of course, the GARCH model, which is implemented, some asymmetric models, such as the eGARCH, GGR, the TGARCH, and the newest popular conditional volatility model, the gas package, gas model that Leopoldo presented the gas package this morning. For conditional distribution, we have the normal and some fat tail one, the student T, and the GED distribution. Also the skewed version with the Fernandez and Steele transformation. So the first step is, of course, to create a specification. So you have two input models, a distribution, a do skew, which is a Boolean indicated, do you want your distribution to be skewed? A do mix is, do you want a Markov switching effect or a mixture effect, which is kind of the same, just we constrain the transition matrix such that we only get a mixture effect and not a Markov switching effect. And do shape independence is, do we want only the conditional volatility process to switch in time, or do we want also the shape parameter of the distribution to shape as well, to change as well? So first step is to create a specification. So some example, we have the simple GARCH 1.1 model. So model SGARCH, distribution a normal. We can do a two-state MSGARCH model. So we input a vector of model and a vector of distribution. And then we're going to do like whatever we want, like very, very complex three-state with the SGARCH, a TGARCH, a eGARCH, three different distributions, some skewed, some non-skewed. You can do whatever you want if you have any reason to do it. If you don't have any reason, well, you better try to find one. So what's inside the specification once you have created one? So if you do the summary, well, you see kind of the information about the specification, some default parameter for the optimizer, and the spec object, the S3 class R object, with an embedded C++ object inside. So the core is made with RCPP and with C++ for computation acceleration, and everything is templated. So if you want to do further extensions, so other conditional process, other conditional distribution, other stuff is very easy, and once we implement something, we know that it will probably work with everything, a single regime or MSGARCH. And well, debugging also, it can be a pain sometimes. So I have we made some illustration. This is the SMI data David showed you earlier as his example. So now we're going to fit an MSGARCH model on that data. So this is from the package DEoptim. In their vignette, they made an example of our MSGARCH model, so we just take back this example, but we fit another kind of MSGARCH model, which is this one, a GGR, student T in both regime, skewed, of course. So we can fit with maximum likelihood estimation. So for now, we have a global optimizer and a local optimizer, DEoptim for a differential evolution for the global optimization, and then NMKB from DFOptim for a local optimizer. Because maximum likelihood and even MCMC we have to start with very good starting parameters. The starting parameters change a lot of the final estimation that you will have, because the likelihood is not very it's not quadratic. It's more local optimum and global optimum. So we get stuck at local optimum often. So we use an heuristic global optimizer just to get good starting value, and then we do local optimization to get the best optimization that we can have. So if we do the summary of the fit, well, we have the fitted parameters. So in this case, what we can see is that from the beta, there's the state 1, which seems to be less persistent than the state 2, given by 0.54 for the state 1 for the beta, and 0.87 for the beta of state 2. If we look at the transition matrix, we'll see that it's very persistent. So if we're in state 1, the probability that we will be in state 1 in the next period, it's 99.8%, which is very high. It's the same thing for the state 2. We see that for state 1, the unconditional volatility is lower than that for state 2. Then we have the log kernel, which is the log likelihood, but with the added priors, and the AIC and the BIC for our model selection if you have competing model and you want to select the best one for your case. We can do, of course, MCMC estimations also with the ADAP MCMC package. You have some control parameter, the burning, the MCMC, the number of draw that you want, the thinning factor, and then if you want to input starting parameters, you can do it with theta 0, which in this case we put those that we found in the MLE estimation. So if we fit that, the summary will give the Bayesian posterior mean, all the same thing of the MLE, but for the posterior mean of the MCMC chain. And well, in the out.smcmc, well, you get the chain also. The summary is just there for a nice view of what you've just fit. So, so what? Now I've done the estimation, what can I do with that? Well, a lot of things. So you can plot like filtered volatility, filtered probabilities, you can do one step ahead simulation, you can do the predictive density for the next step ahead, you can calculate risk measure, predictive risk measure, you have the information criteria for model selection, and then there's more thing to come. So everything's compatible with MLE estimation and Bayesian estimation. So if you're a Bayesian guy, you can do your stuff, and if you're an MLE guy, you can do your stuff also on the package. So some illustration. So if we plot the filtered volatility in the left top corner, you can see the state, the volatility for state 1, and at the bottom you can see the volatility for state 2. So if you see well, it looks like the state 2 is more persistent than state 1, as we've seen in the parameters. So you can infer that in two ways. You look at the parameter, you look at the graph. And you have the filtered probability also. So this is a typical view of a good Markov chain fit, a good MSGARCH fit, is that the volatility is very persistent. So when you switch for a long time, then you come back at some point, and then you switch back at another point. You can see that for state 2, if you look, and there's like the return in more light gray, you see that state 2 was higher unconditional volatility, and this can be seen that when the returns seem more volatile, well, you switch to state 2, which is kind of what we want, because this was kind of an abrupt change in volatility and not just a smooth transition. So we have also the predictive density. So yeah, the function in the MSGARCH package always take an object like a variable. What is an object variable? What is two things? Is it a fitted model or is it a specification? So if you have a specification, you must provide the theta and the y. If you have a fitted object, well, you provide just your fitted object, and it will use the y and the theta that is in the fitted object. It's just for a shortcut if you want to write less code and be more clear in your code. So for the predictive density, the variable x is what you want to evaluate, and there's the Boolean also of do.ids that say, okay, if it's true, do I want to look at in-sample stuff? If it false, do I want to look at out-of-sample stuff? So when it's false, you look at one step ahead. When it's true, you look at in-sample measure. So let's say you want to calculate the log likelihood of your model. Well, you can use a pred function to calculate the log likelihood of all your value in your model. The kernel is the same thing, but it accounts also for the priors in terms of MCMC. So let's look a bit at the predictive density one step ahead. So we make a grid. We plot there both for the MLE estimation and the MCMC estimation. So this is kind of the density of the return that you will expect one step ahead of your estimation window. And with that, well, you can do calculate value at risk and expected shortfall and risk measure since you have the density. So in this case, we see that the MCMC seems a bit more fat-tailed than the MLE estimation. So like we've seen with David, MCMC estimation and MLE estimation does change something when you look at the risk measure. So talking about risk measure, we have a function called risk that calculates the expected shortfall and the value at risk of the model. In sample and out of sample also. This is an example in sample. So it works the same way as the predictive function, the pred. Do that IDS does the same thing in all functions, in sample or out of sample. So you set a level, 0.95, 0.99, depending on what you want. Then you can look at in-sample value at risk. So you just would plot the result. There's nice plotting function that come with the package too, so you don't have too much work to do with ggplot2, since everything is done with ggplot2 already. You just plot it, you look at it, and you decide, okay, is this a good model, is this a bad model? So do I have to remodel my thing, or do I keep this model for my risk measurement? So as I said, there's plans for Google Summer of Code 2017. Leopoldo Catania will work on that with us. So our wish list is mostly improving the starting value strategy for faster optimization. So now we work with DEOptim, but it can be quite slow. So having an improved starting value strategy will really help accelerate the optimization process, and we think mostly about an EM algorithm for that. Multi-step ahead forecast by simulation, parameter constraint. We get a lot of questions on people that want to estimate arch models, Markov switching arch model, and well, we don't have the model, but if you have parameter constraint, well, they can do it by themselves. A standard error for estimate for the MLE estimation, custom MLE and MCMC optimizer with custom priors. So if you want to estimate, put some constraint, you don't think our optimizer are good enough, well, we will let you do what you want to do. Our goal is just provide a framework to estimate Markov switching GARCH, and then giving you the flexibility to do whatever you want to do. New research, or just something specific that you want to do. And then a big one is multivariate model with regime switching calculus. That is a big one that we expect for 2017. So some are currently implemented in the GitHub function, GitHub implementation. The 0.18.4, the current version on CRAN is 0.17.7. So the version on CRAN is kind of bug-free, but the development version is at your risk, but there's more stuff implemented. So if you want to try it out, just do it. And if you have any issue, we encourage you to put an issue on GitHub or ask question afterward during the break. So thank you.